This is the 9th session of your class, chapter number 3, queue and recursion. Last class we have discussed about the concept of the what is a queue and the operations on the queue. There are the two different types of the operations. One is called the insertion and the another one is called as a deletion. So here this is the algorithm for the insertion concept. First of all, what do you mean by the insertion? We have to adding the new element into the existing queue. That process we can call it as the insertion. So here is the algorithm. Let the queue is a linear array that contain the n number of the elements. So front is a pointer that contains the location of the element has to be deleted from the front position, and the rear is a pointer that contains the location of the inserted elements into the rear position. The item, it is the element to be inserted. So here is this is the algorithm. The step 1 is the condition is that if the rear is equal to n minus 1, this condition checks whether the queue is overflow or not. When this condition becomes true, then it prints that instructions, that is the queue is an overflow. When this condition becomes false, go to the next statement, step 2. If the front is double equal to null, when this condition becomes true, it checks whether the queue is empty or not. When this condition becomes true, that is front is equal to 0 and also rear is equal to 0. Or else, when the condition becomes false, rear equal to rear plus 1. That means incrementing the rear pointer. After that, let's go to the step 3, the queue of rear which is equal to item. So this statement is indicated as that the item has to be copied to a rear position, that is a queue of rear position. Then the step 4, return. So this is the algorithm for inserting a new element into the existing queue. So this is the algorithm for an insertion. Then the next slide is the algorithm for the deletion. So deletion, it is a process of the deleting an element from the front position. This process we can call it as the deletion. The algorithm, let the queue is a linear array that consisting of n elements. Here also the front is a pointer that contains the location of the element has to be deleted, and the rear is also pointer that contains the location of the element has to be inserted. Here this algorithm deletes the element at the front position. Here also some of the conditions are to be checked. Step 1, if the front is equal to null, that condition become true, it displays the statement the queue is an underflow. This condition checks whether the queue is empty or not. If the condition becomes true, it displays the underflow. When the condition becomes false, go to the step 2, the item equal to queue of front. The queue of front position, that item has to be stored in the item variable. Go to the step 3, if the front is equal to rear, this condition become true, front equal to null and also rear equal to null. When this condition is checked if the queue has only an one element, or else otherwise the front is equal to front plus 1, incrementing the front pointer, then return the element, that is a step 4. This is an algorithm for the deleting an element from the existing queue. This is the algorithm for deletion. Then go to the applications of queue. So what are the applications of queue? The applications of the queue are, first is a simulation, second is on various features of operating system, the third is a multi-programming platform system, then the different types of scheduling algorithms, then round robin scheduling techniques, then print server routines, then various application software is also based on the queue data structure, then operating system often maintaining a queue of processes that are ready to execute or that are waiting for a particular event to occur. These are all the sum of the applications of the queue, where the queue has to be used in the sum of the applications. Then The next concept is the recursion. Already you studied this concept in the previous semester. What is a recursion? So normally the recursion definition is the function which called itself, that is called as a recursion. So here is a proper definition is it's a process in which a function which called itself directly or indirectly is called as recursion. The corresponding function is called recursive function. Here, using the recursive algorithm, certain problems can be solved quite easily. Some of the examples of such problems are Tavrophoni, in-order, pre-order, post-order tree traversals, DFS of a graph, then Fibonacci, then factorial and binomial coefficient. These are all the some of the examples of here such problems. Here is a recursive program. So in the recursive program, the example one is the binomial coefficient. So here these are all some of the common definitions of the binomial coefficient. A binomial coefficient, that is C of the n comma k, then can be defined as an coefficient of x caps log, that is a power of k, in the expansion of the 1 plus x power n. So this is a normal definition of the binomial coefficient. On the other hand, a binomial coefficient C of n comma k also gives the number of ways. Then discarding order that k objects can be chosen from among n objects. More formally, the number of k element subsets or the k combination of an n element sets. So this is the another definition of the binomial coefficient. So here is a problem. So write a functions that take the two parameters, that is n and the k, and returns the value of the binomial coefficient, the c of n comma k. For example, so your function should return 6 for the n is equal to 4 and k is equal to 2. So it should be written 10 for n is equal to 5 and the k is equal to 2. So the optimal structure is that the value of c of n comma k can be recursively calculated using the following function. So here the functions which are the c of n comma k, that is equal to c of the n minus 1 comma k minus 1 plus c of n minus 1 comma k. The another function is that the c of n comma 0, which is equal to c of n comma n, which is equal to 1. So because the n and n, the value will be same. So here also the c, the n comma 0, that value will be also a 1. Then c of n comma n, that value will be also 1. So this is the recursive program for the binomial coefficient. The as include yesterdayio.h already told the sum of the previous programs. So yesterdayio.h, it is a one header file. It contains the number of the functions like the printf, scanf, so that we have to use it for this header file in the program. So here this is a binomial coefficient functions, that is the coefficients are n comma k. So int the binomial coefficient, it is a function name of the type of the return type is int. Then within the brackets, the n and k, these are all the parameters with the data type int. In opening braces, the base cases which are if the condition is the k is double equal to 0 or the k is double equal to n. So in the previous the functions, that is c of n comma 0, which is equal to c of n comma n, that is equal to 1. So that function is here. The k is double equal to 0 and the k is double equal to n, that returns the value 1. Otherwise, then the recursive functions which are the return the binomial coefficient of n minus 1 comma k minus 1 plus the binomial coefficient of n minus 1 comma k. The values are to be assigned here. Then recursive functions, the functions which called itself, that is called as the recursion. Then closing the function. So this is a main function. The every C and C++ program, the execution must be starts with this main function. Here the value are to be assigned in the n is equal to 5, then k is equal to 2. The values of the C, the percentage of D and percentage of D, this is indicated as it is an integer value. Then print the value, that is print the elements like n is equal to 5, k is equal to 2. Then the binomial coefficient, that is n comma k, that is the value will be, the output is 10. So the output, the value of C 5 comma 2, that is equal to 10. This is the recursive program for the binomial coefficient. Then the example 2, that is Fibonacci series. So here, what do you mean by the Fibonacci numbers? The Fibonacci numbers are the numbers in the sum of the integer sequences. So for example, the 0 and 1, these numbers are to be initialized, so that then the previous two elements are to be added, the next two element as generated. For example, so first element is 0, the second element is 1. 0 plus 1, the next element will be 1. Then the next is, the first element is 1, the second element is 1. 1 plus 1 is 2. Then the next element, the first element is 1, the second element is 2. 1 plus 2 is 3. Then the next element, the first element is 2, the second element is 3. Then the next element is 5. Same as like that, the Fibonacci number are to be sequenced. In the mathematical terms, the sequences of the Fn of Fibonacci numbers is defined by the recurrence relation. So functions which is that the Fn equal to Fn minus 1 plus Fn minus 2 with the seed values, that means the previous values. The f is 0 which is equal to 0, f1 which is equal to 1. This is the initialization. So given a number n, print the nth Fibonacci number. For example, the input n is equal to 2, the output is 1. The input n is equal to 9, the output is 34. That means, so above the Fibonacci sequences, the n, that is second number is an 0, 1, 2, 3, that is n equal to 2, that is second number is 1. The n is equal to 9, that is the ninth Fibonacci number is 34. Here there are the functions of the int fib of int space n that returns the f of nth value. For example, if the n is equal to 0, then the fib of function should returns 0. Then if the n is equal to 1, then it should return the value 1. Then the next condition is, for the n greater than 1, it should return the fn minus 1 plus fn minus 2. So for example, the n is equal to 9. The output is that 34. So this is the recursive program for an nth Fibonacci number. So I should include stdio.h, it is a header file. It contains the functions like the printf. So int fib of int n. So fib is a function name of the data type int. So within the bracket, the n is an argument or the parameter of this function of the type of int. Then the opening block, first it checks the condition. The n is less than or equal to 1. That condition become true, return n. Or else the recursive functions calls the return the fib of n minus 1 plus the fib of n minus 2. The functions are to be repeatedly executing. Then go to the main function. The every C and C++ program, the execution must be starts with this main function. The int n is equal to 9. So we have to find the nth Fibonacci number. So already the previous example. So the nth Fibonacci number, the output which is 34. So here is some of the Fibonacci sequences. We have to find out that one. Then the print the fib of n, the fib of 9th position. Then return 0. So the output of this program which is that 34, because the nth Fibonacci number is the 34. So this is the end of the session. Thank you.